Hi, everybody. It's Mrs. Pound, and I am back with another section of Chapter 1.2 about the nature of matter from Purposeful Designs Physical Science. In our last section, we talked about, and actually the last two videos were the same section, but I broke it up. We talked about some properties of matter. We talked about non-characteristic properties that cannot be used to identify the type of matter. They were things like mass and volume and color, because there are a lot of things are, say, yellow, and you can't use that. We also talked about characteristic properties like density and boiling point and melting point. And we also talked pretty in depth about density. So today we're going to continue on with this chapter in section 1.2.2 and talk about the kinetic theory. So our objectives are to explain the kinetic theory and to describe thermal expansion. The kinetic theory has three assumptions. And kinetic, remember, perhaps you remember from another science class, kinetic means in motion. Okay, kinetic energy is energy in motion. So the first assumption is that all matter is made of tiny particles that are in constant random motion. And those particles are atoms, they are molecules, they are in motion. I have the billiard balls in the background because when we're talking about gases, gases behave a lot like billiard balls. Gases are just flying all over the place until they hit a barrier and then they bounce back in a straight line. But even in the liquid state and the solid state, atoms and molecules are still moving. In liquids, they are sliding past one another. That's why they have flow to them. And in solids, they are shaking in place back and forth. The second assumption is that the speed of the particles is directly corresponds to their temperature. What that means is that as temperature increases, goes up, the particles start to move faster. Okay? And in a solid, when those start to move fast enough, they can break up a little bit and go into the liquid state. And then when they move fast enough in the liquid state, they get far enough, they can go into the gaseous state and fly all over the place, okay? And that all has to do with temperature. Now, that happens at different temperatures for different substances, but it does correspond to their temperature. As they gain more energy, they move faster. And the third assumption is that at a given temperature, the total amount of kinetic energy of the colliding particles remains constant. So if you're at a constant temperature, that kinetic energy is the same. The average is the same for everything in the sample. And finally, we need to talk about thermal expansion. Thermal expansion is the increase in the volume of a substance resulting from an increase in temperature. As you can imagine, as these particles are moving around more and more, they need more space. So they spread out. That is what thermal expansion is. And I have the hot air balloons in the background because you know that as the air is heated up, it expands and fills those balloons. So that was my example for thermal expansion. But that also happens in liquids and it also happens in solids. It's just not as noticeable, but they do in fact get larger. Everything except water. Water actually expands when it freezes. It's a special case. That's why ice floats. But it is really the exception to the rule. For most other things, they expand when they are heated. So our objectives were to explain the kinetic theory, and we're going to be applying that. The reason we're talking about this, we're going to actually be applying this to our discussions about solids, liquids, and gases and the way that why they behave the way they do, and also to describe thermal expansion. So what we're looking forward to in the rest of this chapter is really focusing in on the different states of matter and changes in state.